Hello everyone. In this video, let's discuss about recursion. So recursion is nothing but calling a method itself again and again is called as recursion. It can be called either by directly or indirectly. Okay. So when we talk about recursion, we have to keep two things in our mind. One is base condition. Another one is recursive condition. Recursion is nothing but calling a method itself again and again is called recursion. So when we are keep on calling the method again and again, there should be a point we have to stop calling the recursion. So that is nothing but base condition. In the base condition, I'll mention when to stop the recursion. So the recursive condition is nothing but calling the method itself again and again. So I have to call the same method again and again, right? That we have to give it as a recursive condition. So these are all the two things. Okay. First, let me write a program to find factorial of a number using recursion. So import java.util.star. Okay. Class main. The execution always starts from the main method. Public static void main string args. Okay. So I'm going to create an object for the scanner class. Scanner s equal to new scanner system.in. Okay. I'm going to get the input value from the user int n equal to sc.nextInt. Okay, I've got the input value from the user. Now I'm going to store the value in the variable called result. I'm calling a method called fact. So here I'm calling a method. Okay, so whatever the method is returning, that will be stored in the variable result, and I'll print that value as the output. Okay, so here I have called the method called fact. So if I want to create the method and if I want to call that without the help of object, it should be a static method. So static, it is going to return my integer value fact int n. Okay. So here when we talk about recursion, we have to write the base condition first. So here let's assume the value of n is equal to 5. If the value of n is equal to 5, I'm passing here the value of n is 5. So recursion is nothing but when I call fact of 5, what I have to do? I have to give the base condition first, then I'll tell you how the recursive condition works. So if the value of n is equal to 5, when to stop? So if the value of n is equal to 1, I should stop the recursion because factorial value is 5 into 4 into 3 into 2 into 1. 5 into 4 into 3 into 2 into 1. So when I'm getting the value 1, I can stop this multiplication and the process is being stopped. So if the value of n is equal to 1, I'll return 1 because 1 factorial value is 1. Similarly, 0 factorial value is also 1. So I'll give the condition saying that if n is equal to 1 or n equal to 0, return 1. Else, now we have to go for the recursive condition. Else, what should I do? I have to give return n into fact of n. So this is nothing but recursive call. I'm calling the same method again and again. Okay. So here we have given the value of fact as 5. Fact of 5 I'm passing. What I'm doing, I'm checking the value of n is equal to 1. No, if that is not equal to 1, I'm coming here returning. I have to return a value because the function has returned me an integer value. Return n into. So n value is 5 into fact of n minus 1. Because when I give fact of n, the same value 5 will be keep on getting passed. It becomes an infinite loop. So I'm going to give n minus 1. 5 I have taken, this 5 I have taken. Now for fact of 4, I have to repeat the process. When I go for the next recursive call, what happened? This 5 will be as such. For fact of 4, it is n into, n value is 4 into fact of n minus 1, that is fact of 3. Now when I go for next recursive call, what should I do? 5 into 4 into 3 into fact of 2. Done. Now when I go for next recursive call, what happens? 5 into 4 into 3 into 2 into fact of 1. For next, what should I do? 5 into 4 into 3 into 2 into 1. When I get the fact value as 1, I will not go for the recursive call. Directly I will return the value 1 from this function. That is returned to this place. I have got 2. 2 into 1, 2. 2 is returned to this place. 3 into 2, 6. 6 is returned to this place. 4 into 6, 24. So 24 is returned to this function. 5 into 24, 120. So 120 will be returned by the function fact of 5. That will be given to the variable result. I'll get the output value as 120. Okay, this is what recursion is. Now let me explain the code in a step-by-step order and see how recursion works. This is the function. So the n value is 5. So first I'm calling the method fact of 5. I'm calling the method. So here the n value is 5. N equal to 1, n equal to 0? No, I'll go for else part. Return n into, what is my n value? N value is 5 here. 5 into fact of n minus 1, that is 4. So I'm calling a method called fact of 4. So I'll store the value fact of 4. This is nothing but stack. So in the stack, every recursive call will be stored. First I have stored fact of 5. Now fact of 4. So the same method will be called once again. But here the value of n is 4. Check n equal to 1 or n equal to 0. No. Return n into, what is my n value? 4 into fact of n minus 1, that is 3. So from here I am calling the same method again. But this time the n value is 3. So fact of 3 is called. Okay. Now I'll go here. N value is 3. N equal to 1, n equal to 0? No. I'll go for else part. Return n into, what is my n value? 3 into fact of n minus 1, that is 2. So I am calling a method called fact of 2. So these recursive calls are stored in stack memory. So that's why order, last in, first out. So again I'm calling a method called fact of 2. So here n value is 2. N equal to 1, n equal to 0? No. I'll go to else part. Return n into, what is my n value? 2 into fact of n minus 1. N minus 1 value is 1. So from this method, I'm calling one more method called fact of 1. The recursive call I'll give fact of 1. So the method has to be called fact of 1. Here n value is 1. Check the condition. If n is equal to 1 and n equal to 0, condition is true because n value is equal to 1. So this function is returning me the value called 1. So this function is returning me the value called 1. Where will it return? This method is called by whom? This place. This method is called by whom? This place. So to this place the value 1 will be returned, which means this fact of 1 will return the value called, this will return the value called 1. Where will it return? To the place where I have called here. So here I'll be having 2 into 1. 2 into 1 is 2, which means fact of 2 is returning me the value called 2. So here this returns the value called 1. Done. Now this is returning the value called 2. So this function is done, which means the execution of this function is done. The execution of this function is done, which means this function is returning the value called 2. Where will it return? To this place. To this place it will return the value called 2. So this execution also over. Now I am standing on fact of 3. So here what value has been returned? 2. So 3 into 2. 3 into 2 is 6. So this method is going to return me the value called 6. So it is going to return the value called 6. Where will it return? To this place. Because fact of this is the place where I have called this method. So it returns the value called 6 here. So it will be 4 into 6. So this is done. Now I am standing on fact of 4. 4 into 6 is 24. So this method is going to return me the value called 24. So this is going to return the value called 24. Where will it return? To this place, because this is the place where I have called this method. So it returns the value called 24. So this is done. Now I am standing on this method, fact of 5. So n value is 5. Fact of 4 value is 24. 5 into 24 is 120. So this method is going to return me the value called 120. This will return me the value called 120. Fact of 5 is called by whom? In the main method. So here fact of 5 is called by this place. So it returns a value called 120 here. That will be stored in the variable result. When I try to print the variable result, 120 will be printed. Let me save this and let me run the code. I'll give the input value as 5, see 120. That's all. This is how recursion works. Fine. Here we have seen only one recursive call. It doesn't mean that I should give only one recursive call. We can give two recursive call, we can give three recursive call. Okay, let's take another example to discuss about two recursive calls. Now let's discuss how to write a program to find nth Fibonacci number. Fibonacci number starts with 0 and 1. So 0th Fibonacci term is 0, first Fibonacci term is 1. If you want to find the next term, the logic is sum of previous two terms. So 0 plus 1, 1. So if I want to find the next term, 1 plus 1, 2. If I want to find the next term, 1 plus 2, 3. The next term is 2 plus 3, 5. So Fibonacci series starts with 0 and 1. To find the next term, we have to find the sum of the previous two terms. This is the logic of Fibonacci series. Now, if I give my input value as 5, so this is 0th term, first, second, third, fourth, and fifth. My output is 5. If I give the input as 6, 8 is the answer. Sixth term in the Fibonacci series is 8. This is the logic. Now, let's write it as a program using recursion. Input java.util.star class main public static void main string args. Okay, I'll create an object for the scanner class. Scanner sc equal to new scanner system dot in. I've created an object. I'll get the input value from the user. Int n equal to sc dot next int. So I'm going to take a variable called result. Here I'm going to store the value. I'm going to call the function called fib of n. So I can say method. So whatever the method is returning, that will be stored in the variable called result, and I'll print the final variable result. Okay. So here I have to call a method called fib. So this is a static method. So I don't want to create an object for this. Static int fib int n. So first we have to write the base condition. What is the base condition? If n equal to 0 or n equal to 1, directly I can return the n value, because 0th term is 0, first term is 1. So I can directly return the value n. Else I have to go for the recursive call. So Fibonacci series is thing, but sum of previous two terms. So fib of n minus 1 plus fib of n minus 2. That's all. This is the logic of the program. Let me run the code. I'll give the input value as 5. See, I've got the output value as 5. If I give the input value as 6, the output is 8. So this is the logic of finding the nth Fibonacci number. Now let's see how the recursion works. Okay. So here we have taken the method. So fib of 5. Here let's assume the value of n is 5. Okay. So check the condition. N equal to 0 or n equal to 1? No. So I'll go here. I'll call the recursive call. So fib of n minus 1. What is my n value? N value is 5. 5 minus 1 is 4. So I'll call a method where the value of n is 4. Now I'll go here. Check the condition. N is equal to 0. So fib of 4 has been called. N equal to 0, n equal to 1? No. I'll go here. Fib of n minus 1 is called. N value is 4. 4 minus 1 is 3. So I have to call a method called fib of 3. So a method will be called. Here the value of n is 3. Check the condition. N equal to 0, n equal to 1? No. So I'll go here. I'll call the recursive call. N minus 1. 3 minus 1 is 2. Fib of 2 has to be called. So here when I have two recursive call, once after returning the value to this place, only then the next recursion will be called. So this will be keep on getting called. Now fib of 2 is called. The value of n is 2. N equal to 0 or n equal to 1? No. I'll go to else part. So fib of n minus 1 is called. N value is 2. 2 minus 1 is 1. So fib of 1 is called. Fib of 1 is called. So again I'll call one more method. So here the value of n is 1. N equal to 0 or n equal to 1? Yes, condition is true. If the condition is true, I have to return the n value. So this function will return me the value called 1. Because n value is 1, right? Where will it return? To this place. So it will return to this place. So here fib of n minus 1 value is 1. It has returned 1 here. Now in this function, now because fib of 1, it has returned the value called 1, done. Currently I am standing on fib of 2. So in fib of 2, this recursive call got over. Now I have to call this recursive call. Now I have to call this recursive call. So I'll copy, I'll just paste it here. So n value is 0. When I give n value equal to 0, check the condition. If n equal to 0 or n equal to 2, so fib of 0 has been called. Now fib of 0 is called. Okay. So here, from here, in this recursive call, fib of 0 is called. Okay. So here what happened? So here n value is equal to 0. Fib of n equal to 0, n equal to 1. Yes, condition is true. So this will return me the value called 0. This will return me the value called 0. Where will it return? This function is called by this one. This function is called by this one. So here it will return the value called 0. So now in fib of 2, 2 recursive call over. 1 plus 0, the value is 1. So fib of 2, fib of 0 has returned the value. Now when we are standing in fib of 2, it has to return me the value called 1. It has to return me the value called 1. Where will it return? To this place. It will return the value called 1 to this place. So this function will return the value called 1. Now I am standing on fib of 3. See here in fib of 3. So it has to return the value called 1 to this place. Okay, so 1 plus, now I have to call one more recursive called fib of 2. So already we have called fib of 2 here. See here, we have called here. But still one more time the same recursive call will be called. This is the drawback of recursion. This is the drawback of recursion. So here what happened? Fib of 2 is called. So fib of 2 has been called now. Fib of 2 is called. So here when I go here, check the condition n equal to 0, n equal to 1. No. So I'll go for else part. I'll be calling one more recursive call. So from here I'll be calling one more recursive call, that is 2 minus 1 is 1. Fib of 1 has to be called. So this will call n value is 1. So this is calling a method called fib of 1. Fib of 1 is called. So what happened here? Check the condition. Condition is true. If the condition is true, what happened? It returns a n value. N value is 1. So fib of 1 will return the value called 1. Where will it return? To this place. Because this is the place where I have called fib of 1. So to this place it returns a value called 1. So to this place it returns a value called 1. Plus, now fib of 2 is called. So in fib of 2, n minus 2. So in fib of 2, n value is 2, n minus 2 is 0. So fib of 0 is called. Fib of 0 is called. So here fib of 0, n value is 0, right? So check the condition. Yes, condition is true. If the condition is true, I have to return the n value. What is my n value? N value is 0. So this is returning the value called 0 to this place because it is called by this method called only. So it returns the value called 0. So fib of 0, it has returned the value called 0. Now I am standing on fib of 2. In fib of 2, both recursive call got over. 1 plus 0, the value is 1. So now fib of 2 is returning me the value called 1 to which place? To this place. So fib of 2 is returning me the value called 1, where in fib of 3 for the second recursive call. So here it is returning me the value called 1. Done. Now in fib of 3, both recursive call got over. 1 plus 1, the value is 2. It has to return the value called 2. Fib of 3 has to return the value called 2. Fib of 3 has to return the value called 2 to this place. So it has returned the value called 2 to this place here. Okay, 2 it has been returned. Okay, fib of n minus 2, n value is 4. 4 minus 2 is 2. So fib of 4 I am standing here. First recursive call got over. Now I have to go for the second recursive call. Okay, n minus 2. 4 minus 2 is 2. Now fib of 2 will be called. So the recursive call will call the recursive function called fib of 2. So I'll just write here. n value is 2 here. Fib of 2 is called. So here check n value is equal to 0, n value equal to 1. No. So again I have to call one more recursive call, that is n minus 1. 2 minus 1 is 1. So fib of 1 is called. Fib of 1 is called. So here the value of n is equal to 1. Check the condition, n is equal to 0, n is equal to 1. Yes, condition is true. If the condition is true, this will return the value called 1 to this recursive call. In this recursive call, it is returning me the value called 1. Okay. It is returning the value called 1 plus fib of n minus 2. What is my n value? N value is 2. 2 minus 2, the value is 0. So again, I am calling one more recursive call called 0. So this has been returned. Now I am calling the function called fib of 0. So check the condition. Condition is true. If the condition is true, it returns a value called n. What is my n value? N value is 0. So this fib of n minus 2 is returning me the value called 0 to this place. So fib of 0 is returning the value called 0. Now I am standing on fib of 2. In fib of 2, I have called both recursive call 1 plus 0. The value is 1. So fib of 2 will return the value called 1. So fib of 2 will return the value called 1 to this place, because this is called by this one. It will return the value called 1 to this place. Okay. Now I am standing on fib of 4. In fib of 4, both recursive call got over. 2 plus 1 is 3. So this function will return me the value called 3 to this place. So fib of 4 has returned the value called 3 to this recursive call, because this is the recursive call we have called. Fib of 5. In fib of 5, first recursive call. So here I will have the value called 3. It has returned the value called 3 here. So this recursive call got over. Now I have to call this recursive call, that is fib of n minus 2. N value is 5. 5 minus 2 is 3. So fib of 3. So this recursive call, the same recursive call will be called once again. So this and this. All these recursive calls will be called, and it returns a value called 2, because when I call fib of n minus 1, 4 minus 1, 3. When I call fib of 3, it had returned the value called 2. So when I call fib of n minus 2, fib of 3 once again, all these recursive calls will be executed once again, and it returns me the value called 2. And here it returns a value called 2. So this recursion is also over. Now fib of 5. Now I am standing fib of 5. Both recursive call got over. 3 plus 2, the value is 5. So fib of 5 will return the value called 5 to the main method. It will return the value called 5 to the main method. So here, once after getting the value called 5, that will be stored in the variable result, and when I try to print the variable result, it gives a value as 5. This is how recursion works. That's all.